Hello viewers, I welcome you all to this online class conducted by the SCSTE. I'll be doing the third chapter of mathematics textbook MBOSE syllabus, which is pair of linear equations in two variables. So let us begin. Okay, pair of linear equations in two variables. Okay. So let's start first with the basic thing. Okay. Now, in your lower classes, you have seen equations like this. Okay. X equal to 2, say y equal to -2, right? Okay. Now, graphically, okay. First, you need to check first what is the degree of x here. Okay, the power of x, it is 1. Okay, when there's nothing means there's 1. Okay, here also it is 1. Okay, and the thing is that, okay, linear, okay, we call them as linear, those with degree 1. Okay, it's a linear equation. This is also a linear equation. And graphically, okay, linear equations, okay, like in one variable, it represents straight line. Okay, but straight lines which are parallel to the x-axis and y-axis. Now we'll check first. Now x equal to 2. Okay, graphically, this is the x-axis and this is the y-axis. Okay. Now x equal to 2. Okay, x equal to 2. Now this here is 1 and then 2. So after plotting the points, now you will get that this is the graph of this equation. So we conclude that x equal to 2 is a straight line which is parallel to the y-axis. Okay, remember x parallel to the y-axis. But y equal to -2, okay, graphically, it is actually, now here 1 and then 2, -1, -2. So, the graph of this equation will be passing through this, okay, -2 is here, okay, and it will be parallel to the x-axis. Okay, so just remember x is parallel to y-axis and y will be parallel to x-axis. Okay, so this is the case for a linear equation, okay, in one variable. Okay, now we'll consider the case where we consider a linear equation in two variables. Okay, now the general form of a linear equation in two variables is this one: ax plus by plus c equal to 0, or ax plus by equal to c. Okay, where a, b, c, they are real numbers and a should not be equal to 0 as well as b not equal to 0. If one of them is equal to 0, then it will no longer be a linear equation in two variables, however, in one variable. Okay, so both of them should not be 0. Now, so this is the general form. Let's take a particular equation, say x plus 2y equal to 3. Okay, now this is a linear equation in two variables. Okay, again, y linear, the degree of each of these is 1. Okay, now we will come across this term solution, which is very familiar. Okay, but what does it mean by solution? Now solution is a particular value of x and y such that when you substitute here, it will satisfy the equation. Okay, now most students, they used to get confused. Okay, now let's shift this 3 here, or x plus 2y equal to 3. okay, when they substitute. Now if you take x to be 1, okay, and y to be 1, okay, what happens? Okay, in this case you put only in the left hand side, only in the left hand side. You leave the right hand side. You will get, in place of x you put 1, in place of y you put 1. Now what do you get? You will get 0. So what is there in the right hand side? It's 0. So what can you conclude? That x equal to 1, y equal to 2 is what? It's a solution of this equation. However, when 3 is on the other side, what you need to do is, okay, for this x equal to 1 and y equal to 1, left hand side, okay, it is 1 plus 2 into 1, just the left hand side. And then, in this case, however, you get 3. Okay, you check. What is the right hand side? It is 3. Okay, but still, left hand side and right hand side, they are equal. So, eventually this equation is the same, okay, but it's just the constant, okay, we have carried it to the other side. But you need to check the left hand side should be equal to the right hand side, so that the particular value of x and y is a solution of the given equation. Okay, so this is this one solution, okay, of this equation. Now I can also take x to be, okay, x to be minus 1 and y to be 2. Okay, I'll substitute only in this case, this equation. Left hand side will be what? It will be 1 plus 2 minus 1, sorry, plus 2 into 2 minus 3. It will be minus 1 plus 4 minus 3. So you get 0. Okay, now you see that this is also a solution. This is also a solution. Now when you represent, okay, this equation in a graph paper, okay, now what do you get? Okay, always remember that a linear equation, okay, graphically you will always get a straight line in two variables. Okay, for one variable also straight line. In the case for two variables also it will be a straight line. Okay, so when you represent this graphically, okay, now you will get a straight line. Draw first the x-axis, the y-axis. Okay, 1, 1, and then minus 1 is where 2. Okay, now while trying to plot, okay, sometimes we choose only 2. Okay, 2 solutions or 3 solutions. Okay, and then we join. Okay, and then we join, we get a straight line, and this is the graph of this equation. Okay, but okay, and we used to write here 1, 1. Okay, this point means solution. Okay, and then this one also means solution. Okay, coordinate, okay, represents solution. And one point to be noted also, that each of these points which lie on this line, they are also solution of this equation. So we can conclude that there are infinite number of solutions to this equation. Okay, so that is for a linear equation in two variables. Now we have seen, okay, a linear equation in two variables. Now if I take two linear equations, okay, in two variables, this is the first linear equation in two variables and the second linear equation in two variables. Okay, a1, b1, c1, a2, b2, c2, they are real numbers, and a1, b1, a2 and b2 should not be equal to 0. Okay, now when we take a pair of linear equations in two variables, we call them as simultaneous. Okay, linear equations in two variables. Now we have seen a case where this equation will have solution. Okay, infinite number of solution. This one also will have a infinite number of solution. But when we take a pair of linear equations into variables, what will be the solution? Okay, because they coexist together. Okay, so the solution of this is the common solution. Okay, we'll do that in detail. For example, suppose, if I take a case where x equal to 1 and y equal to 1 is solution of this, then for this to be a solution of this, it should also satisfy this. Okay, so that is what it means when I say the solution of these two. It should satisfy both this as well as this. Okay, common solution. Okay, now, so I've taken two linear equations. Okay, this one. Now by hit and trial method. Okay. Now after putting the values, x equal to 1 and y equal to 2. Let's see. In this, left hand side, what do you get? 2 into 1 minus 3 into 2 plus 4. You will get 2 minus 6 plus 4. They will cancel. Minus 4 plus 4 will be 0. Now for the second equation, now left hand side, will be what? 1 plus 2 into 2 minus 5. So 1 plus 4 minus 5. So this also will be 0. So x equal to 1 and y is equal to 2 is a solution of this simultaneous linear equation of two variables. Remember, it has to satisfy both the equations. And after trying several numbers, I found that I got this as the only common solution, as the only solution of these two. But then there are cases, like this equation, you will find that there are not just only one common solution, but there are more. For example, if I try 1 and y equal to 1, you will find that left hand side will be 1 plus 2 into 1. I get 3, just like the right hand side. Now if I try for this one, for the second equation, this one, 2 into 1 plus 4 into 1, I get 6, just like the right hand side. And then I will try x equal to minus 1, y equal to 2. What happens to the left hand side? It will be minus 1 plus 2 into 2. So I get this to be solution of this. Let's check for the second equation whether or not it will be a solution. So you put 2 into minus 1 plus 4 into 2, you will get 6. So it satisfies both the equations. So we can conclude that being common solution, they are solutions of these two equations. Now you cannot always do by hit and trial method to conclude that this is solution, this is so. Now in this case you find that there will be only one. It means that this is unique. This one is unique, right? The first case, I find that there is only one solution, unique solution. For this one, I find that there are two solutions. So there is, however, a way to know, when they have provided two equations for you, whether they will give you only just one solution or whether two or more or infinite. So that will be given. Now given simultaneous linear equations in two equations. I've considered a general case. General linear equations. Now what you need to do is, okay, don't do that hit and try method, but you just have to remember this table, okay, which I'm going to show you. First, okay, you see here the coefficient of x, the coefficient of y, and the constant. Okay, now A1, okay, and A2, you take the ratio of these two, okay, and then B1 and B2, okay, you take the ratio, as well as for C1 and C2. And remember, transfer the constants or whatever terms lies on the right hand side to this side. Okay. Then after taking the ratio, okay, for A1, A2, B1, B2 and C1, C2, then you compare. You compare first this with this. Are they equal or not equal? We'll consider first if not equal. Okay. Now if A1, A2 is not equal to B1, B2, what happens? Okay. Then if it is equal, okay, however, if A1, A2 is equal, okay, but not equal, okay, but not equal to C1 and C2, okay. And the third case is when all of these three ratios they are equal. Okay. Then this, okay, when the ratio of this is not equal, okay, graphically, okay, because the linear equations always represent straight lines, they will intersect at only one point, okay, when they are not equal. So in order to know, okay, whether they are intersecting or so on and so forth, okay, we check first, okay, just from the coefficients of x and y, you will be able to know, okay. Then if however they are equal but not equal to C1 by C2, they will be parallel, okay, they will not intersect any point at all. However, if all the ratios are equal, we have for the first equation graphically this line, and for the second equation also another line, however, which coincides. Okay, so they coincide. Okay, the two lines they coincide. Okay, so these will be the graphical representation according to the comparison of ratios. Okay. Now algebraic representation. Now in this case, okay. Now what does it mean? Okay, when they intersect, okay, they have what? They have a common solution. Okay, which means that this is also a solution of this line. This is also a solution of this line. I told you, what do you mean by solution of simultaneous? Satisfying both. Common solution. Okay, so we have only one solution. So hence you can conclude that it is a unique solution. Okay, in this case they do not touch, okay, they do not meet, okay, so there is no common solution for these two lines, so hence we conclude that there will be no solution. Just from the graph you can tell, okay, but in this case, okay, each and every point of this line, okay, satisfies both the equation, okay. So, and finally, many solutions. Okay. Now, consistency and inconsistency. Now, consistency means a system of linear equations in which it has at least one solution. In this case, it has a solution, okay, and that is one solution. So, it is consistent. Okay. Now, when it has no solution, we see that it is inconsistent. Okay. The system of linear equations, they are inconsistent. However, when they have infinitely many solutions, consistent says it has what? It should have at least, okay, at least one. Okay, and here infinitely many. So it is. They are actually consistent, sorry, and dependent. Okay, dependent means when they have many solutions. Okay, so this is the table, okay, which will help you to know, okay, whether you will have unique or no or infinitely many solutions. Now we'll go to the case while solving problems by using these. Okay. Now given simultaneous linear equations in two variables. Okay. Now you carry the constants first to this side. 2x plus 5y minus 17 equal to 0. Okay. Then 5x plus 3y minus 14 equal to 0. Then the coefficient of x is a1. Okay, this case b1 and this is c1. Okay, you take along with the minus sign. Okay, so here this is a1. You compare, okay, with the general case. b1 is 5, c1 is minus 17. Then this is, okay, a2x plus b2y plus c2. Okay, so a2 will be 5, b2 will be 3, and c2 will be minus 14. Okay, then you take the ratio of a1 and a2. The ratio of a1 and a2 will be 2 by 5. Then b1 by b2 will be 5 by 3. Okay, then c1 by c2. Okay, 17 by 14. Okay, now you compare this and this one first, whether they are equal or not equal. Okay. Eventually, okay, they are not equal. Okay, just take the same, such that this and this, they are the same denominator. Okay. So 6 by 15. And then b1 by b2 it is 5, 3 into 5 into 5. Okay, so same denominator. However, if you check the numerator, this is 6 and 25. So they are not same. Okay, so they are different. So a1, a2 is not equal to b1 by b2. So when you check from the table, what does this represent? Algebraically, it represents that they will have unique solution. Okay. Now this next question, okay, given this, okay, transfer this, the constants to the left hand side. That is 4x plus 6y minus 7 equal to 0. Okay, and then 12x plus 18y minus 21 equal to 0. Okay, this one, a1x plus b1y plus c1. Okay, so a1 will be 4, b1 will be 6, c1 you take with the minus sign. Okay, so minus 7. So this one represents a2x, b2y plus c2. Okay, so this one is 12, this one is 18, and this one is minus 21. Then you take the ratio, okay, of b1, b2. You get 1 by 3. And b1, b2, you get 1 by 3. And then c1, c2, you get 1 by 3. Okay, so you compare this and this first, they are equal. And then with this also, they are equal. Okay, so therefore, b1, a2 is equal to b1, b2 is equal to c1, c2. So this, according to the condition, it represents that they have infinitely many solutions. So this next question, okay, you have to find the value of k, okay, given these equations, okay, whereby it has unique solutions according to the condition, Okay, unique solution, no solution, and then finally many solutions. Okay, so our aim is what? To find the value of k according to the conditions. Okay, so now you take first these simultaneous linear equations. Okay, so given kx minus y equal to 2 and then 6x minus 2y equal to 3. Transfer the constants to the other side, you will get this. Okay, and then 6x minus 2y minus 3 equal to 0. A1, B1, C1. Okay, so here A1, remember to take the negative sign as well. Okay, here minus 1. Okay, so minus 1, C1 is minus 2. Then A2, B2, C2. Okay, so A2 it is 6, B2 it is minus 2, and C2 it is minus 3. Then you take the ratio. A1 by A2 is k by 6, and then B1 by B2 it is minus 1 minus 2 will be half. Okay, and then C1 by C2 it is minus 2 by minus 3, which is 2 by 3. Okay, so after finding the ratio, now you have to find k for which the first condition says that it has unique solution. Okay, now when it has unique solution, now what is the condition? This and this, they are not equal. Okay, so we'll write. Okay, now since they have, for the condition where they have unique solution, A1 by A2 should not be equal to B1 by B2. Okay, substitute what is A1 by A2, it is k by 6, and then B1 by B2 it is half. Okay, then carry 6 to this side, you get k to be not equal to 3. Okay, so what does this mean? Okay, now if you put this 3 in the first linear equation, okay, if you put 3 here, okay, and the second is this equation, it means that these two, they will not have unique solution for k equal to 3. Okay, so it means that you should not take k to be 3 for this to have unique solution. Okay, now we'll go to the second condition where it has no solution. Okay, okay, now the first condition is, okay, when they have unique solution. Okay, so for unique solution we have this one. Okay, A1 by A2 should not be equal to B1 by B2. You substitute what is A1 by A2, it is k by 6, then not equal, then you get half here. Then from here, k is not equal to 6 by 2. Then k should not be equal to 3. Okay, now you take those two equations, kx minus y equal to 2, and then 6x minus 2y equal to 3. Now replace, okay, suppose you replace this by 3. Okay, this k by 3. Now what do you see? Okay, now this is A1, A2, okay, A1, A2, okay, you take the ratio as well, 3 by 6 you will get half. Okay, and then for B1 by B2, it is minus 1 and minus 2, half. So what do you see? When you put k to be 3, you get that they will be equal. Okay, so that's why k should not be equal to 3. Okay, if they are equal, okay, for these two, either they will be parallel or coincident. But for unique solution, the lines they meet at only one point. Okay, so if you put k to be 3, the lines will not intersect. Okay, so that's why k should not be equal to 3. Okay, so we'll go to the second condition where they have no solution. Okay, next condition is no solution. Okay, now no solution is when the comparison of ratios is this. Okay, you substitute what is a1 by a2, k by 6, and then this is half, and then this one is 2 by 3. Okay, now from these three, okay, you take only these two. Okay, taking only these two terms, k by 6 equal to 1 by 2. Then from here, you see that k should be equal to 3. Okay, now what does this mean? Okay, k equal to 3. Again, you substitute in the equation. Okay, 6x minus 2y equal to 3. Now this is 3x minus y equal to 2, and 6x minus 2y equal to 3. For the first, okay, a1 by a2, okay, it is 3 by 6, you will get half. For the second, okay, b1 by b2, again you will get half. For c1 by c2, you will get 2 by 3. Okay, after transferring to the other side, you will get 2 by 3. So this is the condition. You see, these two are equal, and these two are equal, but a1 by a2 is not equal to c1 by c2. Okay, and okay, let me write this here. a1 by a2 is not equal to c1 by c2, and b1 by b2 also is not equal to c1 by c2. Okay, so you see that when you put k to be 3, these two are equal but not equal to c1 and c1 by c2. And you will see that when you draw the graph of these two equations, okay, this, you will get parallel, okay, which represents no solution. Okay, so this is possible when you take k to be 3. Okay. Okay, the third condition is when the system of the equations, they have infinitely many solutions. Okay. Now for infinitely many solutions, okay, what happens to the ratio is that they are all equal. Okay. Now, however, when you check, now if you check for B1 and B2, don't check for A1 and A2 because K is unknown. Okay, you check first for B1 and B2 for the known, okay, known numbers. Okay. Now you see here that B1 by B2 is half, but C1 by C2, it is 2 by 3. Here it says that all of them should be equal. But when you check, okay, in this case they are not equal. Okay. So B1 by B2 is not equal to C1 by C2. So it contradicts this condition. Okay. So we can conclude that we cannot find any value of k, okay, whereby it will have infinitely many solutions because it doesn't even satisfy at all. So no value of k can be found out. Okay. So hence no value of k. Now the third condition is when the system of equations, they have infinitely many solutions. Okay. Now the condition for infinitely many solutions is, okay, where the ratios, they are all equal. Okay, but if you check, okay, for B1 by B2, it is half. Okay, and for C1 by C2, it is 2 by 3. Now what can you see? B1 by B2 and C1 by C2 is not equal. So you write B1 by B2 not equal to C1 by C2. But here it says that all of them should be equal. So that's why it contradicts this condition. Okay, contradicts. However, okay, we have seen in the first case that for k not equal to 3, okay, any value of k except 3, you will get different equations. Okay, for, you see, for this one. Okay, if you substitute k not equal to 3, these two equations, they will give you unique solution. Okay, many. Okay, you keep on changing, say 1, 2. Okay, now you will find that each of these two will give their own solution. Okay, unique solution. Okay, but if you put k equal to 3 here, okay, you find that they give what? Parallel lines. Okay, so what can you conclude is that for k not equal to 3, okay, there are unique solutions for the different equations. But for a particular value of k, okay, for a particular value of k, however, okay, for a particular value of k, okay, we cannot have these two equations to have infinitely many solutions. Okay, so hence we can conclude that there does not exist any value of k for which these two equations will have infinitely many solutions. Okay, so we can say does not exist. Okay, so with this, okay, I have described about the basic, okay, about a pair of linear equations in two variables. Okay, so in the next class we will be doing by graph method. Okay, how to solve these a pair of linear equations in two variables. So until then, thank you.